In this lesson, we're going to go over exponents. Specifically, we'll evaluate exponents and we'll multiply and divide in expressions involving exponents. First, when we talk about positive exponents, they come in the form of a to the power b, where a is our base, b is the exponent, and the exponent tells us how many times to multiply the base by itself. So for instance, if we have something like 7 to the third power, this means 7 times 7 times 7. Or if we have, let's say, x to the fourth, this is x times x times x times x. Example 1, evaluate. 3 squared means 3 times 3, which is positive 9. Negative 2 to the third power, notice how the negative 2 is in parentheses, which means that this whole thing, negative 2, is our entire base that we're going to multiply by itself 3 times. So this means negative 2 times negative 2 times negative 2, which gives us negative 8. Example C looks a little bit different. The negative is on the outside of the parentheses, and when we have something on the outside like that, you can imagine that there's a negative 1 there. So this means negative 1 times 4 squared. If you follow the order of operations, we do the exponents before we do the multiplication. So in this case, we have negative 1 times 4 times 4, which gives us negative 16. Negative exponents. So negative exponents have a to the power of minus b. So we'll do a little demonstration using 3 to whatever power I have here to go over some facts about negative exponents. So 3 to the third is 27. 3 squared, 3 times 3 is 9. And 3 to the first is just 3. Notice how each time we divide by 3, and so 3 to the 0 power is just 1 if we continue the pattern of dividing by 3. 3 to the negative 1, if we divide by 3, this is 1/3. So notice 3 to the negative 1 became 1 over 3. And so that's a way that we can rewrite our negative exponents. If we divide by 3 again, we get 1 over 9, which is the same thing as 1 over 3 squared. So that made the exponent positive. And then 1 over 3 cubed is 1 over 27. So negative exponents cause us to think about fractions. And as we can see, a base with the exponent of 0, except 0, is going to be equal to 1. Example 1, evaluate. And now we have examples with negative exponents. So 8 to the negative first power, if you want to think about it as a fraction, put it over 1. To make the exponent positive, it changes positions in the fraction. So in this case, since 8 to the minus 1 is in the numerator, we're going to bring it to the denominator. And now the exponent becomes positive. 8 to the first power is just 8, so our final answer here is 1 over 8. Example B, 1 over 5 to the negative first power. In this case, you can do a couple of different things. We can either take this as 1 to the negative 1 over 5 to the negative 1. To make the exponent positive, the base with the negative exponent changes positions in the fraction, which means that the 5 to the negative first will go to the numerator, and the 1 to the negative first will go to the denominator. And when they change positions, the exponent is positive, so this is just equal to 5. Another way to do this problem is to flip what's inside first, so 1 over 5 becomes 5 over 1 to the positive first power, which becomes 5 to the first over 1 to the first, and again we get 5. Part C, negative 3 times 3 over 5 to the 0 power. Remember, with order of operations, we evaluate the exponent first. 3 over 5 to the 0 power is just 1, so we end up with negative 3 times 1, which is just negative 3. Example D, or part D, we have negative, and then we have 2 to the 0 power. Remember, when you see a minus sign in front, you can think that there's a negative 1 there and that it's being multiplied. 2 to the 0 power is 1, so we have negative 1 times 1, which is equal to negative 1. Now we're going to simplify bases with negative exponents that have a variable instead of a number. Anytime you're asked to write your answer, you're asked to write it using only positive exponents. So the same applies. X to the minus 2, you can put it over 1. This x to the minus 2 comes to the denominator, it changes positions in the fraction, and the exponent becomes positive. For part B, 1 over y to the negative fourth, y to the negative fourth is going to move to the numerator, and the exponent becomes positive. So this is 1 times y to the fourth, or just y to the fourth. Multiplying and dividing exponents. When multiplying same bases with exponents, we add the exponents together. So as a demonstration, x squared is x times x. I'm going to do a big circle to denote the multiplication. And then x to the third is x times x times x. So in total, we have 5x's being multiplied together. Remember, the exponent tells us how many times to multiply the base by itself. So this becomes, there's 1, 2, 3, 4, 5, x to the fifth. Notice the relationship of the powers we started with to the powers we ended with. This is why, when you multiply same bases with exponents, you add the exponents. We can do something similar for dividing. X to the seventh is x times x times x times x times x times x times x divided by x squared. Here we have some cancellation, and we're left with 1, 2, 3, x to the fifth again. And again, notice the relationship between the powers we started with to the powers that we ended with. We subtract the exponents when we divide same bases with exponents. Example 1, simplify. Write your answer using only positive exponents. Since order doesn't matter in multiplication, we can rewrite this to put our numbers next to each other and our same bases next to each other. Negative 5 times 3 is negative 15. And y to the fourth times y squared, if we add the exponents, gives us y to the sixth. Example 2, I'm going to do this problem a couple of different ways. 42 x to the fourth times y squared divided by 7 x to the third y to the seventh power. So if we write this out, 42 x to the fourth y squared divided by 7 times x to the third y to the seventh. 1, 2, 3. Okay. Then we have some cancellations. 7 goes into 42 6 times. X's cancel. We're left with 1. And y's cancel. So notice what we have left on the top and on the bottom. On the top we have 6x, and on the bottom we have 1, 2, 3, 4, 5 y's. So this is one way to solve this problem. The other way is to use the rules of exponents. So I'm going to draw a line to denote I'm doing it differently. You would still do 42 divided by 7, which is 6. X to the fourth, x to the third, this would be x to the 4 minus 3. And then we'd have y to the 2 minus 7, which gives us 6, x to the first, y to the negative fifth. Now the directions say to write our answer using only positive exponents, which means the y to the negative fifth would need to come to the denominator to make the exponent positive. So this would give us 6x over y to the fifth power. Simplify. Write your answer using only positive exponents. This is called power of a power rule with exponents, and I'll show you how they come up with that. So y to the fifth 4 times means y to the fifth times y to the fifth times y to the fifth times y to the fifth. And you could write this all out. Y times y times y times y times y. That's 5 times over and over and over again. Or apply what we learned about multiplication where we add the exponents together. 5 plus 5 plus 5 plus 5 is y to the 20th. And notice the relationship between the powers we started with to the powers we ended with. When you have a base with an exponent and you raise it to another power, you end up multiplying the two exponents. Thank you for watching. If you have any additional questions, please feel free to contact me or utilize one of the free resources available to you.